Hello, I am Meghna from IIT Bhubaneswar and I made a couple of audio effects on Simulink and I would like to show you the same. First, this is a basic audio processing system wherein I take a speech signal and pass it to the audio device, spectrum analyzer and the time scope. And this is another path wherein I have introduced a discrete filter and then I am passing it to the similar output devices. Next, I have created another system which has a multimedia file that is being added to the same multimedia file with a particular delay and a particular gain. The output of this addition is then taken back and then delayed by some amount of time and then it is added again. And after this I am clipping the result to provide some distortion and then I am outputting the same to my output devices. Also I am outputting my original signal for comparison. This is I am showing the echo effect, the reverberation effect and the distortion effect. These are common audio effects. Next I'll show you an advanced audio effect. This is flanger effect wherein I pass my multimedia file in a delay section where the delay is provided by the addition of a sine wave and a constant multiplied with some gain. Then I add the output of that delayed sine wave to my original signal and then I pass it to my output devices. So I have created a combined setup of these audio effects and I would like to show you how it works. So this is my flanger subsystem which has the flanger components which I showed you in the previous model. Next, this is my echo subsystem which has the components of my that is needed for the echo. This is the distortion one which just has a distortion block and I am selecting which effect I would give by manual switches, and this is my reverberation block. And then I have outputted the same to various output devices like spectrum analyzer, time scope and audio device. So let us check how this works. So first I'll show you how the original signal must sound like.
The discrete Fourier transform of a real-valued signal is conjugate symmetric. The discrete Fourier transform of a real-valued signal is conjugate symmetric. The discrete Fourier transform.
This is how the original signal must sound like. Next, let me check flanger.
The discrete Fourier transform of a real-valued signal is conjugate symmetric. The discrete Fourier transform of a real-valued signal is conjugate symmetric. The discrete Fourier transform.
This is how flanger audio effect sounds like. To detect flanger, you will need like a microphone, a good audio set. Next, let us see how echo sounds like.
The discrete Fourier transform of a real-valued signal is conjugate symmetric. The discrete Fourier transform of a real-valued signal is conjugate symmetric. The discrete Fourier transform.
So you can actually hear the voices echoing. And this is how distortion sounds like.
The discrete Fourier transform of a real-valued signal is conjugate symmetric. The discrete Fourier transform of a real-valued signal is conjugate symmetric. The discrete Fourier transform.
The signal appears a little distorted. And next I'll show you how reverberation sounds like.
The discrete Fourier transform of a real-valued signal is conjugate symmetric. The discrete Fourier transform of a real-valued signal is conjugate symmetric. The discrete Fourier transform.
You can actually hear the infinite delayed samples being added. So this is how my setup works. Thank you.